Good morning, Tahmina Khan is here. In today's video, I will explain you the concept of remainder and factor theorem. It is a topic from CAIE syllabus O-level additional mathematics. The code is 4037. So before I begin, you can see on top, I have written my blog address where I have put the links of all my previously made videos for your easy access. Okay, so let's start. What is remainder and factor theorem? Now, whenever you start any topic, you must know what you have to cover in that topic, number one, and then go stepwise. So basically, there are 4 things you need to know in this topic. Number one, polynomial identities. What are those and how to work on it, what to find out, how to find out. Then what is a remainder theorem, what is a factor theorem, and how to solve cubic equation. Okay. For solving cubic equation, I will just put a link of my A-level mathematics because this concept is required there also, and I have already put it up in my A-level site. So I will just put a link there and then you can see solving cubic equation from there. So let's start with polynomial identities. Number one thing in this chapter you need to know. Now identities are represented by this notation, 3 parallel lines, and identities mean same thing. I'll explain you in a while. Polynomial mean many terms. For example, sum of many terms, 8x square minus 2x plus 3. So there are 3 terms. So this is a polynomial. And you must have here positive power, not negative, not fractional. I'm not going into that detail, just telling you this much information. Okay, so now let's pick up this term, 8x square. This is called coefficient. So coefficient of x square. And the degree of a polynomial in x is the highest power in it. So for example, the highest power of x is 2 here. So I can say the degree of the polynomial is 2. And in this case, if I see this example, I can say the degree of the polynomial is 3. This is just for information. So let's start with first question or example on polynomial identity. So first example I have picked up from exercise only from the textbook. So it is given this thing and you have to find out the value of a and b. Now there are 2 methods to do so. I have explained both methods here. First method is comparing the coefficient, in which you expand this and then compare the coefficient with this side. And in second method you substitute the values of x. Now let me tell you one thing here. In identity you can put any value of x because it is true for all values of x. So at times equals to sign will be written here, but after this it will be written here for all values of x. So when equation says for all values of x, it means basically that equation is your identity, right? Okay, so now let's see first method. So I'm expanding this right hand side. Here I have done expansion, simple algebraic expansion, and after that I am rearranging. You see cube term, these 2 are square term, minus 2x square, these 2 are x term. So I'm writing cube, square, x and constant. I'm writing in descending order. Now I will compare the coefficient. X cube and x cube is same, forget it. Second term is minus 2x square. Okay, so you don't need it, because there is nothing unknown. You have to find the value of a and b. There is no ab in these 2 terms, so leave them. Let's see this term, 4 and x. Here the coefficient of x is a and 1, and you have to find out. So you need to compare this term now. So you will say comparing the coefficient of x. This is the way we write it. Comparing the coefficient of x such that I have picked up the coefficient of x from the left hand side, which is 4, equals to, from the right hand side the coefficient of x is a plus 1. So this is what I have written and found the value of a. 4 minus 1 is 3. Now I have to find out the value of b. Now these 2 terms are without x. So it means these are my constant, and here it is 3. Sometimes a student think that because it is just one term here, so they will have only one term here. This is not necessary. You can have more than one term. But all those terms which are without x are called constant. So 3 is equals to minus a plus b. I'm repeating, these two terms are without x, so they are called constant terms. And this side, left hand side, it is 3. So you can say 3 equals to minus a plus b. So I'm saying comparing the coefficient of x naught, this is like a small circle, okay, not, it's like this. This is called x naught, which means constant. So 3 equals to minus a plus b. The value of a I have already found, so I'm substituting here to find the value of b. So this is how I find the value of a and b using the method comparing the coefficient. Now let's see the second method, which is called substituting method, and I can substitute any value of x. Okay, so now first of all I'm substituting 1. The reason is when I will put x1 here, 1 minus 1 will be 0, and 0 multiplied by anything is 0. I will be left with b. If you will pick up any other value, you can solve then also, but it will be little lengthy then. I will show you in a while. So let's put x equals to 1, and you will put all the way from here till here. Wherever is x, you will replace it by 1. So 1 cube is 1. 1 square is 1. 1 twos are 2. 1 times 4 is 4. Plus 3. 1 minus 1, you can see. Then 1 square is 1. So I am writing it down. Now this is 0. 1 minus 1 is 0. 0 multiplied by this bracket is 0. So I am writing here. Plus b. And this is equals to 6. So my b is 6. This is the value we found when we were using comparing the coefficient method. Okay, so now I am taking another value of x because there were two unknowns a and b. So far I have found the value of b only. So now I am taking x equals to 0. Choice is mine, I can take any value. So wherever I have x, I am writing 0 here. 4 zeros are 0, 2 zeros are 0. You can see here 0 power 3 is 0. Throughout, wherever I have x, I am writing 0. So this, and when I simplify, I get 3 minus 6. I have brought this 6 to this side. 0 minus 1 is minus 1, and here I have only a, so minus a. So a equals to 3. So this is an example with the help of which I have explained to you two methods, comparing the coefficient and substitution method. Now let's pick a little tricky question. This is also from the book. Okay, so the question is saying, given that 4x cube minus 6x square plus this is equals to this. It is still here, right? Now if you remember function you have done in maths, so sometimes you write equation like this, f of x equals to whatever the function is here. Now right now this q of x mean there is some function. Now function mean like this is one function expression, right? Or 2x plus 3 or x plus 1. So here is some expression which you don't know. So question is saying it is given to you and qx is some polynomial. Find out the value of a and b. Now in these type of questions you cannot do comparing the coefficient method. You know why? Because you don't know what polynomial is here, so you cannot open the bracket. Like here you can multiply this by this, but what is here? Maybe it is x plus 1, maybe it is just x, maybe it is x minus half, you don't know, right? So that's why you cannot apply here the method which is comparing the coefficient. So the only choice left here is that you have to do what you have to do? Substitution method, right? So let's see. So here I have just written once again to explain that since you cannot expand this term and you cannot compare left hand side and right hand side, so you can use only substitution method. Now why substitution method? There are two unknowns a and b, so you need two substitutions. Now if you see here, whatever the term is here, this term and this term, they are all multiplying. So if I take one substitution as 2, x is equals to 2, this whole will become 0. And if I take x equals to minus 1, then minus 1 plus 1 will be 0, and this whole will become 0. So when the question is of this type, one unknown function, you always take the substitution of x, which can make this term disappear. Does this make sense to you? Because if you take any other value of x, then again you will not be able to solve it because you don't know what function is here, right? So let's take x equals to 2 and x equals to minus 1. So when I take x equals to 2, in this function, I am substituting the value of 2 everywhere, wherever it is x. So now 2 minus 2 is 0, so this whole term will become 0, because 0 multiplied by anything is 0. Okay? So I am left with 2a plus b. So I got one equation. And now I will substitute x equals to minus 1. Okay, so now I am taking x equals to minus 1 to make this term 0, because minus 1 plus 1 will be 0. So wherever I have x, I am writing minus 1 there. So minus 1 plus 1 0, and this term will become 0. That's why I have written here 0. And it is ax, so a into minus 1 is minus a. So I got another equation. One equation I got when I substituted x equals to 2, and second equation I got when I put x equals to minus 1. So I'm solving those two equations simultaneously, and I got the value of a and b. I would recommend that you can put this video on pause here and try to do this on the copy yourself. Then it will make more sense. But anyway, if you are doing it for recap the concept, it's fine. Now let's see what is a remainder theorem. What does it say? Now you know from long division of numbers that this is your dividend, this is your divisor, this is called quotient, and this is called remainder, right? And from here there is one thing which is very important, and at times when tricky questions come, we need to understand or apply this concept. And what is that? 16 is equals to, yani ke dividend is equals to divisor multiplied by quotient, 3 into 4 plus remainder. So remember this, it's extremely important concept which is like a common sense, but at times when it is needed, students forget to apply it. Okay, so remember this concept. In the exercise, textbook, in miscellaneous, there is, I think, question 1 or 2 where this concept is needed to apply. If you want to try yourself, you can. Okay, so now remainder theorem says if you have a polynomial, right? Polynomial means the divisor I'm talking about here. Divisor carrying, dividend. And this is your divisor. Okay, I will take an example of a number to make it more clear, but right now I'm talking in general term. So if you have a polynomial and you have to divide it by this, then rather than doing long division, what you do, you from the divisor get the value of x. So put the divisor equals to 0 and get the value of x. Right now it is a. I will take an example in which it will be a number. And then that value of x plug in here in your polynomial and you will get a remainder. Let's see it with the help of example. It will make more sense to you. Now this is your polynomial function and it is divided by 2x plus 1. Find remainder. So the technique is whatever the divisor is given to you, because it is divided by this, put it equals to 0 and get the value of x. Now this value of x plug in here and here, right? Because you are dividing this polynomial by this number. So I'm repeating, from the divisor you get the value of x by putting it equals to 0. So I'm getting minus half. So I'm substituting minus half everywhere. This is just an indication that when I write f of minus 1, minus half, it doesn't mean f multiplied by minus half. No. You have done functions in maths. It simply means in the expression wherever you have x, replace it by minus half. And this, and then solve it. The answer you will get will give you remainder. This is what remainder theorem says. So this basically gives you remainder. At times a student says, Miss, now what do I write in place of this? You don't have to write anything. You don't have to do anything with this. This is simply giving you hint that whatever is coming on the other side, like it is minus 12, that is the remainder when you divide this polynomial by this. Let's take this example now. In this example, this function is divided by this and the remainder is 32. You have to find the value of a. So let me say that f of x equals to this, just like in function we do in maths, right? So I'm calling this polynomial as f of x. My divisor is x plus 2a. And I have to find the value of a when my remainder is 38, when I divide it by this. So I will put it equals to 0 and I will get the value of x, which is minus 2a. So it means when I will substitute in this polynomial minus 2a, my remainder will be 32. This is given in the question. I'm repeating that I am calling my polynomial as f of x. So it means f of minus 2a, because now my x is minus 2a. So f of minus 2a will give me remainder, which is equals to 32. It is given in the question. So now in this polynomial, wherever I have x, I will write minus 2a. You can see, right? And in place of this, I will write 32 because this gives me remainder. And then I'm simply solving like an algebra. And I got a equals to plus minus 2. So this is the value of a. Let's take another example from the book only. It is considered by most of the students as a difficult example. So that's why I've picked it up. Now question is saying when you divide this by x plus p and x minus 2q, right? Find the value of p minus 2q because your remainder will be same. So when you divide this by x minus 2q or x plus p, your remainder will be same, and find p minus 2q. Question is not saying find the value of p and find the value of q. No. Question is saying what is the value of p minus 2q. So let's see. So I'm saying let f of x equals to this. So whatever the polynomial dividend is given to me, I'm giving it a name f of x. Now two divisors are given to me, x plus p and x minus 2q. I'm putting it equals to 0. In my mind or on the paper, it's up to you. So if I put it equals to 0, x equals to minus p. And if I put it equals to 0, x equals to 2q. Right? Now question is saying that when you divide this by this and this, you get the same remainder. So now in place of x, everywhere I will write minus p. And then in place of x, I will write 2q. And I will put it equals to each other. Because they give us what? Remainder. And question is saying remainder is same. So after that, I'm plugging in the values minus p and 2q and then simplifying it. Till this step, everybody gets it right in my experience. After that, students get confused, right? I have to keep in my mind that I have to find the value of p minus 2q. Now if you see here, there is no p minus 2q. Can you notice? Okay, so you have to manipulate it. That's why this question seems difficult to students. I'm bringing this term to this side and taking this term to this side. Okay, 3 I have cancelled from both sides. After that, I'm taking 2 common out, and from here I'm taking 2 common out. 2 from here and 2 from here. Simple algebra. Okay. Now if you see, what is this form? Do you remember anything? If you remember algebraic identity a square minus b square, it has taken that shape, right? So instead of 4q square, I can write 2q square. So this is my a square and b square, which is equals to a plus b, a minus b. So I'm writing p plus 2q, p minus 2q. This 2 which I have taken common out is cancel out, because if you bring it to the other side here, it will cancel out. Now from here also I have taken 3 common out. So if you notice, p plus 2q is present on both sides. So after cross multiplication, it will cancel out. So you are left with p minus 2q equals to 3. This is the value you had to find out. Okay. Now let's start factor theorem. Factor theorem is simple once you understand remainder theorem. Let's see through number. If you do long division, 2 and 5 are factor of 10, right? Because remainder is 0. So the method will remain same, but now your remainder will be 0. So let's see the question, how do we do it? Again, I have taken example from book only. So for example, question is saying for what values of k is this polynomial, which is given to here, exactly divisible by x minus 2. Now when the question says exactly divisible, it means remainder is 0. Okay, remember this. So it means when you divide this polynomial by this, your remainder is 0. So technique will remain same. I'm calling this or giving a name to this polynomial f of x, just like function. Okay, we say y equals to this. I'm saying f of x equals to this. And now it is divided by x minus 2. So I'm putting it equals to 0. So it will be x equals to 2. So this value of x, which I am getting from divisor, I will put here everywhere. Can you see? I have put it everywhere. Now this gives me remainder. This whole thing is equals to remainder. And what is your remainder? 0. Why? Because this is dividing it exactly. So in place of this, I will write 0. And I will simply solve it like algebra. And it will help me to get the value of k, which is 2. So I got the value of k. Let's see another example. Now this polynomial is exactly divisible by this quadratic. Find the value of a plus b. Now again remember, question is not saying find the value of a and b, which means separate value of a and separate value of b. Rather, question is saying find the value of a plus b. Now interesting thing is here, this is a quadratic equation, right? So, and this is a divisor. What we always do in polynomial, in remainder and factor theorem, we find the value of x from divisor by putting it equals to 0. So this is a quadratic equation. I will factorize it. Can you notice? When I put it equals to 0, I factorize it and I get two values of x. X equals to 2 and minus 1. So this type of tricky question comes where linear function is not given to you. So you have to apply factorization method to get the value of x. Okay, so I'm calling my polynomial equals to f of x. Now I will put both the values here, 2 and minus 1, and then I will put this equals to 0. Reason? Because this is exactly divisible. Okay, this divisor is dividing this polynomial exactly. It means remainder is 0. And this always gives us remainder when we substitute the value of x here. So first I am putting 2 here. And of course everywhere, wherever it is x, I am replacing it by 2. And then in place of this I am writing 0. I got one equation. Then I am substituting second value of x, which is minus 1. You can see. And then I am replacing it by 0. I got another equation. Now I will make c a subject and then substitute here. Why c? Because question was saying find the value of a plus b. So I need to eliminate c. So from this equation, I made c a subject. It is 1 plus b minus a. And I'm substituting here. After that, I'm simply manipulating to bring a plus b on one side. And it is giving me minus 3. Make sense? You can see it. And with this, I will end this video, solving cubic equation. I will just put up the link of the video which I have put on my A-level side, because there I have explained solving cubic equation by 3 different methods, which is the requirement of O-level also, exactly same. So I will put a link of that video. Thank you very much for watching this video. If you have learned something, please do give comments to help me improve my videos, and do press like and subscribe button so you can get indication of my next videos. Thank you. Take care. Bye bye.